In this episode, we are moving into a subject that feels exciting on the surface, but becomes much more serious once you look at it through a risk lens. Because emerging technologies often arrive with promise long before organizations fully understand their side effects. New tools and platforms can improve speed, lower cost, create better customer experiences, and unlock entirely new business models. At the same time, they can introduce uncertainty, weak assumptions, hidden dependencies, and exposures that are not obvious when leaders first approve them. For someone new to see risk, this is a very important idea to absorb early. Technology risk is not limited to old systems, broken controls, or known threats. It also appears when something new is adopted quickly, understood poorly, or trusted too much simply because it sounds modern, efficient, or innovative. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good place to begin is by defining what we really mean by emerging technology. The term does not only refer to inventions that are brand new to the world. In a practical business sense, a technology can be emerging when it is new to the organization, changing rapidly, not yet fully governed, or being applied in ways that create unfamiliar risk. That means the challenge is not just the novelty of the tool itself. The challenge is the gap between what the organization wants from the technology and what it truly understands about the technology's behavior, limitations, dependencies, and control needs. A system may be widely discussed in the market and still function like an emerging technology inside a company if internal teams lack experience with it. That distinction matters because risk does not come only from invention. It also comes from immature use, weak oversight, unclear ownership, unrealistic expectations, and decisions made faster than the organization can adapt its control environment. Organizations adopt emerging technologies for understandable reasons, and those reasons are often legitimate. Leaders may see an opportunity to automate repetitive work, improve data analysis, strengthen customer engagement, accelerate decision-making, reduce infrastructure costs, or respond to competitive pressure. Business teams may also feel that waiting too long creates its own risk because competitors may move faster, customers may expect new capabilities, or regulators may begin demanding better resilience and visibility. This means emerging technology risk should never be framed as a reason to reject change by default. That would be too simplistic and not very useful. The real task is to understand how innovation creates both opportunity and exposure at the same time. A risk-aware organization does not treat new technology as automatically dangerous, and it also does not treat innovation as automatically beneficial. Instead, it asks whether the value is real, whether the assumptions are sound, and whether the organization can manage the uncertainty that comes with adoption. One of the most important beginner lessons is that emerging technology risk usually appears in patterns rather than isolated surprises. New technologies can create confidentiality issues if they expose data in unexpected ways, integrity issues if outputs become unreliable or difficult to validate, and availability issues if the organization becomes dependent on platforms or services it cannot fully control. There may also be legal, regulatory, operational, reputational, financial, and strategic consequences that spread beyond the technology team. A new system can change how decisions are made, how data is collected, how vendors are used, and how quickly errors scale across the organization. In other words, the technology is rarely the whole story. The associated risk often comes from the surrounding ecosystem, including people, processes, contracts, governance, training, resilience, and the simple fact that rapid adoption can outpace careful thinking. That is why risk professionals look beyond the tool itself and examine how the organization is changing around it. Artificial intelligence, AI, is a strong example because it shows how quickly value and risk can grow together. Organizations are drawn to AI for analysis, automation, pattern recognition, forecasting, content generation, customer interaction, and operational efficiency. Those benefits can be meaningful, but the associated risks are broader than many beginners first assume. AI systems can reflect bias in underlying data, produce outputs that sound confident even when they are inaccurate, create privacy concerns if sensitive information is used carelessly, and make accountability harder when decision logic is difficult to explain clearly. There is also a tendency for people to trust highly polished outputs simply because they appear fast or sophisticated. That can lead employees to defer judgment when they should be applying it more carefully. From a CRISC perspective, the lesson is not that AI is inherently unsafe. The lesson is that powerful automation and analytics require strong governance, good data practices, clear use cases, human oversight, and realistic limits on where the organization should rely on the results. Machine learning, ML, adds another layer to that conversation because it depends heavily on data quality, model behavior, and changing conditions over time. A model can perform well during testing and then drift away from reliable performance as real-world conditions change, user behavior shifts, fraud patterns adapt, or source data becomes less representative. This creates a subtle risk because leaders may continue relying on outputs that appear stable while actual accuracy is gradually declining in the background. ML also raises questions about explainability, especially in environments where decisions affect customers, employees, financial outcomes, or regulatory obligations. If the organization cannot explain why a model reached a conclusion, it may struggle to justify decisions or identify when something is going wrong. For a new learner, the important point is that emerging technologies often require ongoing validation rather than one-time approval. The presence of advanced analytics does not reduce the need for control. In many cases, it increases the need for monitoring, challenge, and clear accountability for how automated decisions are used. The Internet of Things, IoT, is another area where associated risk grows quickly because connected devices often spread technology into places that were not historically treated as part of the organization's core information environment. Smart sensors, cameras, industrial controllers, medical devices, building systems, and consumer-like workplace devices may all gather data, communicate over networks, and affect physical or operational processes. That means IoT risk is not only about data exposure. It can also involve safety, reliability, maintenance, vendor dependence, patching challenges, and weak visibility into what devices are actually present in the environment. Many organizations discover that IoT expands faster than governance, especially when devices are deployed for convenience or operational benefit without being fully integrated into security and asset management practices. A risk professional, therefore, has to ask very practical questions. What data is being collected? Who manages the devices? How are they updated? What happens if they fail? And how much business disruption could follow if a connected device becomes unavailable, compromised, or inaccurate? Cloud-native platforms, edge computing, and highly distributed architectures also fit into this conversation because they change where systems run, how services connect, and who holds operational responsibility. Even if cloud technology itself is no longer new, the ways organizations combine hosted services, automation, microservices, and distributed processing can create emerging risk in practice. These environments can scale quickly and support innovation, but they also increase complexity. Data may move across regions, services may depend on multiple third parties, and failures may be harder to isolate because functionality is spread across interconnected components rather than sitting inside one familiar system. The associated risk often lies in misunderstanding the shared responsibility model, assuming visibility exists where it does not, or failing to track how deeply the business depends on external platforms. Beginners sometimes think distributed architecture automatically means resilience, but resilience depends on design, observability, failover planning, and governance. A complex environment can be flexible and fragile at the same time if the organization builds quickly without fully understanding its dependencies. Blockchain and other distributed ledger ideas are useful examples because they remind us that not every emerging technology risk comes from malicious compromise alone. Sometimes the risk comes from misunderstanding what problem the technology actually solves. Distributed systems can offer benefits related to transparency, traceability, and tamper resistance in certain contexts, but they do not automatically fix weak input controls, poor business logic, flawed governance, or unreliable surrounding processes. If inaccurate or fraudulent information enters the system, the organization may simply preserve bad data in a more durable way. There can also be concerns related to privacy, scalability, legal interpretation, and operational complexity, depending on how the technology is used. For new learners, this is a valuable reminder that technology does not replace judgment. A modern architecture can still support a weak process if the underlying assumptions are poor. In risk terms, the question is never just whether a technology sounds advanced. The real question is whether it matches the business problem and whether associated controls are mature enough to support the way it will be used. Emerging technologies also create important third-party and supply chain risks because organizations rarely build or operate everything themselves. New capabilities often arrive through vendors, cloud providers, software platforms, data partners, managed services, or specialized development firms. That means the organization may depend on outside parties for uptime, patching, incident response, data handling, compliance support, and even technical explanations of how the technology behaves. If those dependencies are poorly understood, the organization may adopt a capability faster than it can manage the relationship behind it. There is also the danger of concentration risk if too much business activity depends on one external provider or one narrow segment of the market. A vendor failure, contract dispute, service interruption, or security incident can quickly become the organization's problem even when the original event happened elsewhere. Risk professionals therefore have to look beyond product features and ask about resilience, support models, auditability, exit strategies, and whether the organization could continue operating if the third party became unavailable or failed to meet expectations. Privacy and ethical concerns become especially important when emerging technologies collect, combine, infer, or act on information in new ways. A tool may gather more data than users realize, analyze behavior at a deeper level than leaders expected, or make inferences that create uncomfortable or unfair outcomes even when no rule was obviously broken. This is one reason why lawful use is not always the same thing as sound risk management. An organization can sometimes deploy a capability that is technically allowed and still cause distrust, reputational damage, or internal harm because people feel watched, misjudged, or manipulated by systems they do not understand. Ethical risk is often dismissed by beginners as too soft or abstract, but in practice it can influence brand trust, employee morale, customer loyalty, regulatory attention, and public reaction after an incident. The bigger lesson is that risk management is not only about stopping attackers or preventing outages. It is also about understanding how technology changes relationships, expectations, and the organization's obligations to the people affected by its decisions. A very common mistake with emerging technology is to focus on features and ignore governance. Teams may rush to pilot something new because the business case sounds compelling, but they may not decide who owns the risk, who approves use cases, what data is allowed, how outputs are validated, or when use should stop if control objectives are not being met. Without governance, even a promising technology can become a collection of disconnected experiments, each with different assumptions, weak documentation, and unclear accountability. Good governance does not have to kill innovation or slow it to a crawl. Its real purpose is to make sure the organization knows what it is doing, why it is doing it, who is responsible, and what level of uncertainty it is accepting. For CRISC learners, this is a major theme that will appear again and again. Risk becomes much harder to manage when ownership is vague, approval is informal, and no one is clearly accountable for monitoring whether the technology continues operating within acceptable boundaries. Scenario thinking is one of the best ways to evaluate associated risk because it forces the organization to stop speaking in broad optimistic language and start asking what could actually happen. What if an automated decision tool produces a harmful pattern that nobody notices for months? What if an IoT device fails during a critical business process? What if a cloud-based service that supports a major customer workflow becomes unavailable during peak demand? What if a vendor handling emerging analytics exposes sensitive data or changes its terms in a way that affects business continuity? These kinds of scenarios help reveal dependencies, business impact, control gaps, and decision points that generic conversations often miss. They also make it easier to compare opportunity and exposure in practical terms. A strong risk discussion is rarely about whether a technology is good or bad in the abstract. It is about understanding how the technology behaves in the organization's specific environment, what could go wrong, how likely or severe that outcome might be, and what controls or governance changes are needed before adoption expands. Another misconception worth correcting is the belief that emerging technology risk can be handled once, at the beginning, and then considered finished. That idea fails because emerging technologies change quickly. Vendors update features, threat actors adapt, regulators publish new expectations, business teams discover unexpected uses, and technical dependencies evolve after launch. A system that seemed low risk during a pilot can become far more significant once it is integrated into core operations or exposed to real customer data at scale. This means risk assessment should be iterative, not one and done. Monitoring, review, testing, stakeholder communication, and policy updates are all part of staying aligned with a changing environment. For someone new to the field, this is a helpful mindset shift. Risk management is not a wall built once and forgotten. It is a continuing discipline of attention, adjustment, and evidence. Emerging technologies demand that discipline even more strongly because the surrounding conditions are often moving almost as fast as the technology itself. When all of this comes together, the most useful takeaway is that emerging technologies should be approached with disciplined curiosity rather than fear or blind enthusiasm. They can create major business value, but they can also amplify uncertainty, complexity, and dependency if the organization adopts them faster than it can govern them. A strong C-risk mindset looks for both sides of that reality at the same time. It asks what problem the technology solves, what new exposures it creates, who owns the decision, how controls will work, and whether the organization can continue trusting the technology as conditions change. For beginners, that is the core lesson to hold on to. New technology is not risky merely because it is new, and it is not safe merely because it is useful. The real question is whether the organization can understand it well enough, govern it clearly enough, and monitor it consistently enough to capture the value without accepting more uncertainty than it truly intends to carry.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.